Newsweek published this story under the headline The Science of Doom on November 23, 1992. In light of the Perseid meteor shower of 2017, Newsweek is republishing the story. It comes screaming out of the sky like the scud from hell, bigger than a mountain and packed with more energy than the world's entire nuclear arsenal. It hits the atmosphere at 100 times the velocity of a speeding bullet, and less than a second later smacks into the ground with an explosive force of 100 million megatons of TNT. The shockwave from the crash landing, traveling 20,000 miles an hour, levels everything within 150 miles. Simultaneously, a plume of vaporized stone shoots up from the impact site, blasting a hole through the atmosphere and venting hot debris. The vaporized rock cools, condensing back into hundreds of millions of tiny stones. As they streak to the ground over the next hour, they heat up, and soon the very air grows hot pink. Steam hisses from green leaves, buildings and even trees burst into flame. Nitrogen and oxygen in the atmosphere combine into the nitric acid. Any surviving life, crawling out of a burrow or cave, gets pelted with a rain as caustic as the acid in a car battery. That's what astronomer Henry Melosh of the University of Arizona calculates would happen if something 6 miles across fell from space and smacked into Earth. 6 miles is the size of the comet believed to have hit the planet 65 million years ago, killing off the dinosaurs and 2/3 of all life. 6 miles also happens to be the probable size of the Swift-Tuttle comet. Swift-Tuttle is the peripatetic frozen dirt ball that an astronomer last month declared has a 1-inch 10,000 chance of hitting Earth on August 14, 2126. All an astronomer need do is spy the pockmarked surfaces of planets and our own moon to realize that it's a cosmic shooting gallery out there. Mercury, Venus, Earth and dozens of moons have been cratered over the eons by a blizzard of falling asteroids, comets and other stuff that can manage to stay in its own orbital lane. But it dawned on scientists only recently in the 1940s that this pinball chaos hasn't stopped. An estimated 20 tons of particles, most no bigger than grains of sand, fall on the ground each day. Of course, sometimes the missiles are bigger than sand grains. Thousands of meteorites as big as a lump of coal fall every year, usually harmlessly. But one smashed through a garage roof in Illinois in 1938, and another totaled a car in a New York City suburb last month. No injuries in either case. Ironically, the misses are more worrisome than the hits. On March 23, 1989, an asteroid a half-mile across missed Earth by just 700,000 miles. No one saw it coming. If it had arrived a mere 6 hours later, it might have wiped out civilization. Earth runs its course about the Sun in a swarm of asteroids, says astronomer Donald Yeomans of NASA's Jet Propulsion Laboratory in Pasadena, Calif. Sooner or later, our planet will be struck by one of them. Tech Science emails and alerts get the best of Newsweek Tech Science delivered to your inbox unless, of course, some other dreadful fate strikes first. Economics may be the dismal science, but now the hard sciences physics, astronomy, geology have skipped past dismal to confront nothing short of doom. Will it be ice, a cataclysmic climatic change known as the next ice age, or will it be by fire, the ballooning of the life-giving sun, consuming us in one fiery blast? And what, if anything, we can do to forestall any of this? Think of it as the ultimate environmental movement. Can science save the planet Earth? So much for friendly skies. Earth has taken major hits at least 139 times, according to the tally of impact craters constantly updated by Richard Grieve of the Geological Survey of Canada map, page 59. 5 or 6 new craters are discovered every year. You can identify an impact crater by the presence of minerals that form only in huge pressures of a crashing meteorite, or by telltale patterns of shattered rock. Crater Lake in Oregon comes from an old volcano, not an asteroid hit. And these 139 are just the craters that haven't been erased by erosion, covered by Earth's moving crustal plates, are hidden under the sea. The 1978 explosion in the South Pacific, once suspected of being a nuclear test, is now thought to have been an asteroid hit. Such finds have made astronomers scurry to start a census of just what threats lurk in the solar system. Led by Eleanor Heelan of the Jet Propulsion Lab, Eugene Shoemaker of the U.S. Geological Survey and Tom Gerrels of the University of Arizona, they scan the skies whenever they can wrest telescope time from the diggers of black holes. Thanks to better telescopes and computerized searches, the pace of discovery has picked up. Gerrels' group counts asteroids that orbit close enough to Earth to pose a threat. In the late 1980s, they were finding 15 asteroids a year of the size that could eliminate human society. Now they're up to 35 a year and gunning for 100 annually by 1994. On just 4 summer nights in 1990, Helan found 3. One asteroid that crosses Earth's orbit is 20 miles wide, large enough to wipe out all traces of life. It's not headed our way for as far into the future as astronomers have calculated. There are a half dozen bigger than 5 miles across. And those are only the ones we know about. A NASA panel estimated in January that there are between 1,000 and 4,000 asteroids that cross Earth's orbit and are bigger than a half-mile across, the size that could send civilization back to the Stone Age. Only 150 are known. Of the 300,000 or so Earth-crossing asteroids at least 300 feet across, we know hardly any. Maybe we should make their acquaintance. Last month, astronomer David Rabinowitz of the University of Arizona reported that as many as 50 asteroids, with diameters between 16 and 160 feet, come closer to Earth than the Moon. Asteroids, chunks of rocks or metal, float mostly between the orbits of Mars and Jupiter. Occasionally, one bumps another toward Earth. This cosmic billiards ensures a constant supply of new asteroids with orbits that might intersect Earth's. Other threats come from farther out, in a region beyond Pluto called the Oort cloud. It is named for its discoverer, Dutch astronomer Jan Oort, who died 2 weeks ago at 92. The cloud is filled with chunks of frozen gas and dirt comets. Think of the Oort cloud as the solar system's bench, the place where comets not quite ready for the starting lineup await their big break. It comes in the form of a gravitational kick from a passing cloud of dust and gas. Once sent into the game, the comet speeds toward Earth as the sun's heat turns its frozen gases to vapor. The comet grows a tail and its surface erupts with jets of gas and dust. About 200 comets revisit Earth's environs more often than once every 2 centuries. They include Swift-Tuttle, named for 2 American astronomers who saw it during the Civil War, and Halley, after the 17th century English astronomer who predicted its return. But no one knows how many never-before-seen comets are heading our way. For those coming in from the far reaches of the solar system for the first time, we have virtually no chance of seeing them until they get close, says astronomer Clark Chapman of Science Applications International Corp. in Tucson, Arizona. We could discover every asteroid and still 10% of the threatening objects wouldn't be found until they were literally upon us. Comet Swift-Tuttle is not among that 10%. It's been observed at least twice before, but it could still pose a considerable threat. Last seen in 1862, it was spotted by a Japanese amateur astronomer again in late September. On November 7 it passed within 110 million miles of Earth, not even a close call. Swift-Tuttle causes the Perseid meteor showers every August as it orbits the Sun. Little bits flake off. When Earth crosses this path, the litter streams through the atmosphere and glows. Brian Marsden of the Harvard-Smithsonian Center for Astrophysics has calculated that Swift-Tuttle will return, after swinging out past Pluto in a 134-year orbit, on August 14, 2126. On that visit, it will come much closer to Earth than it did this year. And, Marsden said last month, because Swift-Tuttle's jets might nudge it ever so slightly off its appointed course, it might even hit Earth. Ever since, the doomsday faxes and email have been flying at the speed of light. Scientists don't dispute that comets erupt with jets as the sun warms their surface. Like thrusters on a spaceship, the eruptions shift the comet's orbit ever so slightly. But is there reason to think Swift-Tuttle's jets will push it onto a collision course to sea? JPL's Yeomans used the observations of 1992 and 1862 to calculate Swift-Tuttle's orbit. Using that orbit, he calculated how close the comet would have come to the Sun in its previous visit in 1737, assuming no mysterious course-altering jets. Bingo, he nailed the actual orbit to within a day. The 1737 orbit was recorded by a Jesuit missionary in China. This seemed to establish that so far, at least, Swift-Tuttle's orbit has not been shaped by jets of the kind of strength that might cause a collision in 2126. Yeomans concludes, the comet will pass no closer to the Earth than 60 lunar distances, 14 million miles, on August 5, 2126. There is no evidence for a threat from Swift-Tuttle in 2126 nor from any other known comet or asteroid in the next 200 years. But Marsden still thinks the grandchildren of today's toddlers might be in for a nasty shock in their old age. There are still unanswered questions, he says. That's why I've said to astronomers, get more observations. Swift-Tuttle is only one of thousands of potential doomsday rocks. It's not exactly prudent to wait for the sky to fall, so in January the NASA panel called for the creation of an early warning system. Using 6 to 3-meter telescopes, astronomers could spot more than 90% of the asteroids bigger than about a half-mile. It would cost $50 million to build the SpaceGuard survey and $10 million a year to run it. That's a 4 cents per American insurance policy. But there could still be unpleasant surprises. There's no practical way to get an early warning about smaller asteroids or many comets. Once astronomers calculate orbits for the thousands of asteroids and comets whose paths intersect Earth's, they will almost certainly find a few things are on a collision course. The extent of Earth's danger depends, of course, on the size of the object likely to strike it. Truck-size such collisions come at least every decade. But anything smaller than 30 feet across or so, though packing a wallop of 50,000 tons of TNT, usually fragments and burns up in the atmosphere. Such an asteroid or comet may produce a meteoric fireball, a burst of light and heat, but it's usually too high in the atmosphere to cause significant damage. Building size: a rocky asteroid with a diameter between 30 and 300 feet blows up in a blinding flash when it smacks into the atmosphere, as did the comet or asteroid that exploded over Tunguska, Siberia, one June morning in 1908. Exploding 5 miles up with the force of 12 megatons, it annihilated reindeer 30 miles away, ignited the clothes of a man 60 miles away and leveled more than 700 square miles of Siberian forest. A sturdier asteroid, one made of nickel and iron rather than stone, would plunge to the ground without exploding. If one the size of the Tunguska rock hit the rural United States, calculates John Pike, Director of Space Policy for the Federation of American Scientists, it could kill almost 70,000 people and cause $4 billion in property damage. It could also flatten buildings 12 miles away, according to the NASA panel. If it hit an urban area, there would be upwards of 300,000 deaths. If it hit in a seismic zone, it could trigger earthquakes topping 7.5 on the Richter scale. Mountain-size objects larger than 300 feet across hit Earth once every 5,000 years or so. If an asteroid 600 feet across fell in the mid-Atlantic Ocean, calculates astrophysicist Jack Hills of Los Alamos National Laboratory, it would produce a massive tidal wave, 600 feet high, on both the European and North American coasts. Hills speculates that just such a hit wiped out the fabled Atlantis. Larger asteroids, half a mile across, hit every 300,000 years. That kind of collision, says Pike, would surely rank as the greatest catastrophe in human history. Thanks to the cloud of dust thrown up by this million-megaton explosion, there would be no crops anywhere for a year. In contrast, a comet of this size, since its ice and frozen gases fragment easily, would probably break up in the atmosphere and explode like the Tunguska hit. City-size asteroids are comets larger than 3 miles across, like Swift Turtle, hit every 10 million to 30 million years. According to one calculation, if the dinosaur comet thought to have been about 6 miles across hit in the Gulf of Mexico, it would have created a wave 3 miles high. 900 miles away, the mammoth wall of water would still be 1,500 feet high. Such an asteroid landing in the Gulf of Mexico would cause floods in Kansas City. The impact would make entire continents burst into flame, block sunlight and make agriculture impossible. Humans might go the way of the trilobites. At a conference this year at Los Alamos, researchers had no shortage of ideas about how to protect against cosmic catastrophe. Some of the more ingenious came from weapons scientists. Shooting down a comet is not so different from shooting down an ICBM, except that the ICBM is closer, and thus easier to spot, and slower, so easier to hit. And given the promised demise of the Star Wars program under the Clinton administration, shifting over to anti-comet defense may not be a bad career move. At the conference, Edward Teller called for the development of a bomb 10,000 times more powerful than anything in today's arsenal. One researcher thought dropping antimatter onto the threatening asteroid or comet would do the trick. When antimatter meets matter, they annihilate each other in a puff of pure energy. He didn't specify how to get antimatter up to the asteroid, since at the moment rockets are made of matter, not antimatter, and so would be destroyed as soon as the antimatter cargo was loaded. Or, a rocket could drop a solar sail onto an asteroid or comet. The sail would catch the charged particles constantly streaming out from the sun, and thus alter the object's course, carrying the threat safely past Pluto. No one has figured out how to deliver the sail, though. Dropping a heat source of some kind onto a comet looks good on paper. 2. The heat would induce jets that, like thrusters, would steer the comet away from Earth. An asteroid doesn't have enough volatile ingredients to make jets. But jets are not predictable. They might accelerate the comet toward Earth. Such sticking points help explain why the motto of the Los Alamos Conference was, as one enthusiast cheered, "Nukes forever." So far, the only source of energy powerful enough to deflect a mountain-sized rock traveling at 15 miles per second, 54,000 miles an hour is nuclear. The basic idea is to use a massive explosion to deflect the asteroid or comet from its earthbound path. The sooner the better. A push of even a few hundred feet, if applied millions of miles away, could work. Waiting until the killer rock was closing in would require more energy than any nuclear weapons ever built. Where to deliver the bomb depends on what the object is. A comet is fragile. A blast on the surface could shatter it into huge pieces that together could kill even more Earthlings than the original. The NASA panel therefore endorsed a standoff blast diagram. One or more nuclear-tipped missiles, launched on an American Titan IV or a Russian Energia rocket, would home in on the comet optically or by radar. The missiles would be programmed to explode the bombs beside the comet, kicking it off its earthbound path either directly or by inducing orbit-altering jets. No one would argue against deflecting an asteroid or comet capable of dooming all agriculture for a year, let alone one able to cause the extinction of mankind. But there is deep disagreement over whether we should also protect against the impacts that happen every decade or so, like Tunguska, says Clark Chapman. Even these small events can kill people, but they are 1,000 times less likely to do so than earthquakes, floods and the other things that kill people all the time. Expense is one factor. Because an early warning system could not detect objects 150 feet across more than a few weeks ahead of their arrival, to protect against them would require keeping dozens of nuclear-tipped rockets fueled up, armed and ready to go 24 hours a day. That would cost several $1 billion a year. Even then, success against a fast-closing object would be far from certain, especially since the rockets would get only one chance to score a hit. Keeping nuclear-tipped rockets at the ready would also be dangerous. Accidents happen. Terrorists happen, too. During a human lifetime, there's roughly a 1 in 10,000 chance that Earth will be hit by something big enough to wipe out crops worldwide and possibly force survivors to return to the ways of Stone Age hunter-gatherers. Those are the odds of dying from anesthesia during surgery, dying in a car crash in any 6-month period, or dying of cancer from breathing the automobile exhaust on the Los Angeles freeway every day. Killer asteroids and comets are out there. And someday, one will be on a collision course with Earth. Of all the species that ever crawled, walked, flew or swam on Earth, an estimated 2/3 became extinct because of an impact from space. Mankind may yet meet that fate, too. But we're the only species that can even contemplate it and, just maybe, do something to prevent it. The Argo of Apocalypse asteroid, an irregularly shaped object, made of stone or metal, that orbits the Sun between Mars and Jupiter. Collisions or chance tugs from Jupiter can knock it off across Earth's orbit. Asteroids are thought to be parts of a planet that never gelled. Comet, one of the hundreds of dirty snowballs, chunks of frozen gases and dust that travel in elongated orbits from beyond Pluto to near the Sun. The Sun's warmth drives off particles and gases to form the comet's tail and jets. Meteor, the streak of light created when a tiny object, such as a speck of comet dust, enters the Earth's atmosphere. Most of these falling stars burn up before reaching the ground. Meteorite, any natural object arriving from space that has survived the plunge through Earth's atmosphere and reaches the ground. It is usually a mass of stone or metal. OORT cloud, the blizzard of comets beyond Pluto. Only when one is kicked out by the gravity of a passing cloud of dust and gas does it leave the Oort cloud and speed toward the Sun and Earth. Diversionary tactics. Asteroid. To divert an asteroid heading toward Earth would require a nuclear-tipped rocket. A Titan IV could home in on the asteroid and detonate a bomb on its surface. This could provide enough of a kick to nudge the asteroid off its catastrophic course. Comet bombing. A comet could fragment this fragile ball of dust and ice into millions of chunks that could still hit Earth. But exploding a nuclear device beside it could melt some of the frozen gases and turn them into jets which would cut like thrusters on a rocket and divert the comet from its deadly path.